The Arduino 101 is a board packed with features that make it a very interesting option for prototyping, especially of applications in the space of wearables and mobile applications. This Arduino features an Intel Quark processor on board specifically designed for powering mobile low-power applications. It runs a real-time operating system which Intel plans to open source in the near future. This will give users the opportunity to tap into the processor's internal resources. At the moment, users can use the libraries that Intel has provided to access the built-in 6-axis accelerometer and gyro, Bluetooth Low Energy, and real-time counter features. Apart from the Intel microcontroller, the Arduino 101 can be programmed with the basic Arduino IDE and is compatible with the vast majority of the Arduino Uno style shields. The included level shifters ensure that the board will work with either 3.3 volts or 5 volt shields and peripherals. A flash module provides additional storage space. Let's take a closer look at the Arduino 101. Hi, in this section and lectures I will be discussing the Arduino 101, which was introduced earlier in 2015. The Arduino 101 is a very capable board with a lot of very interesting features, but the fact is that it's just not as simple as the Arduino Uno, and therefore is, in my opinion, not the best way to get started. But it is an advanced Arduino board, and that is why I discuss it in this course. It's a very interesting board as well, and I think it's my personal favorite after the Arduino Uno, of course. Let's have a look at my comparison table to get a feel of what is special about the Arduino 101 and how it differs to other Arduino boards. So right from the beginning, we'll see that the Arduino 101 features an Intel Quark architecture instead of the AVR architecture that most other Arduino boards feature. In fact, the Arduino 101 is the only board, in addition to the Arduino Galileo, that feature an Intel chip on it instead of an Atmel chip. So the Arduino 101 has got a Quark microcontroller, as so does the Intel Galileo. Now, I'll be talking about the Intel Galileo in a separate section, but I just wanted to mention that these two boards share the same architecture. The Intel Quark microcontroller is basically a 2-core CPU. It's got one core, the Quark core, which is dedicated to running an real-time operating system, which is responsible for the various functions and executing the sketches that you upload. And it's got another core that is basically the microcontroller, which is responsible for interacting with the digital input-output pins and the various peripherals like the built-in gyroscope, for example, and 6-axis accelerometer. The real-time operating system is unique in Arduino boards. It's not a firmware that you upload in the form of a sketch to an Arduino Uno, for example. It's a resident operating system. At the moment, the user does not have access to this operating system, but Intel has promised to open source it and make it available to the community. So this operating system is only available via hooks internally to the Arduino side of the board, the sketches, and exposed through the Arduino libraries to the user, but you don't have direct access to it. Once Intel releases the source code and the specifications of the RTOS, then users will be able to extend it and create new capabilities for the Arduino 101 on top of what is available to the user today. So my opinion is that the Arduino 101, thanks to the Intel Curie microcontroller will become a lot more interesting as a platform to develop applications in the near future. A few more things about the Intel Curie module. It is a very good attempt by Intel to enter the space of makers. It is very small sized chip with very low power consumption, meant to be used by devices that are always on and small, ideal for wearables, for example. Its inbuilt components, especially things like the 6-axis accelerometer, and its performance as a microprocessor means that it's very capable. It's got integrated DSP, digital signal processing, for example, which means that it's got a built-in capability to analyze signals and extract information from noisy signals like that from a 6-axis accelerometer. With a sizable flash memory, so it can fit large programs, and if those large programs don't fit in this memory, then you can always hook up an external flash like we have here on the Arduino 101 board. So this chip here is an I2C external flash memory module. The Curie page on the Intel website has a few interesting applications of this technology, things that people have made. It's worth having a look at. Have a look at the fact sheet that is available from the Intel website. So low power, 384 kilobytes of flash memory with 80 kilobytes of static RAM, an integrated digital signal processing sensor hub, pattern matching technology, Bluetooth low energy integrated 6-axis combo sensor with accelerometer and gyroscope, and a battery charging circuitry, also part of the core technology with nothing else to add. Back to our comparison table. The Arduino 101 is a 3.3 volt device, but it is 5 volt tolerant input outputs because of the level shifters that are included on the board. So each of these 3 chips is a level shifter and is dedicated to one header. So this level shifter is responsible for the analog headers for the analog pins on this header, this one for these digital pins, and this one for these digital pins here. That means that you can take pretty much any one of your existing headers for the Arduino Uno and just plug them onto your Arduino 101, and regardless of whether they are 3 volts, 3.3 volts or 5 volts, it should work without any issues at all. So it's a very nice feature. It's a very safe board to use thanks to these level shifters. The input voltage that you can plug in through the barrel connector, just like the Uno, are 7 to 12 volts. You have 14 input-output pins, 4 of which, these 4 here, provide PWM capability. We've got 6 analog pins down this side here. The maximum DC current per input-output pin is 7 milliamps. That's enough to drive an LED or some other small load, but for other things like relays and motors, you will need to provide external power. Got 196 kilobytes of flash memory integrated in the Intel Curie chip, 24 kilobytes of static RAM, and the board operates at 32 megahertz. Same size as the Arduino Uno, same weight almost. The weight is very small, and as far as the peripherals are concerned, we've got an integrated Bluetooth low energy. You can see the antenna etched onto the board. We'll be doing a demonstration of this capability later. We also have a built-in gyro and accelerometer, and I'll be doing a demonstration of this later. So they can use this feature to track the movement of the device in space. There's also a real-time counter inside the chip that you can use it to determine the passage of time and actually to tell the actual time and date once you configure it. If you plug in a battery, you'll be able to have a device that can maintain time and date. I'll be giving you a demo about that as well. Let's have a look at the schematic of this board now. So here's the board, and in the core we've got the Curie microprocessor from Intel. We've got the headers up on the sides. We've got the power input. You can power the device from the USB port, the battle connector, and also there is a voltage in pin here, VIN. So the VIN pin and the battle connector are hardwired, so both of them will go via a voltage regulator and they can accept 7 to 12 volts. You can power the device directly by plugging 5 volts to the 5 volt pin or 3.3 volts to the 3.3 volt pin, but you have to be sure that these power sources are regulated, because if you do that, you bypass the onboard voltage regulator and you run a risk of damaging the board if they're not properly regulated. You can see the level shifters here. Each level shifter is responsible for its own header. The external flash connected by SPI, the battle power input as well that goes via the voltage regulator. As far as programming is concerned, nothing really changes. The method of programming the Arduino 101 is the same as programming any other Arduino board. You will use the Arduino IDE with the appropriate plugin for the Arduino 101, as I'll show you in the next lecture. So no additional knowledge is required. You notice that there are 2 reset buttons on the board. The first one is the reset button. The second one is the master reset button. The difference between these 2 buttons is that if you press the reset button, then all you do is you restart the running sketch. But if you press the master reset button, then you restart the real-time operating system and the sketch. In the unlikely event that the real-time operating system is causing problems, for example, you are not able to upload a new sketch, then you can reset the device by pressing the master reset button. It's the same thing as unplugging and plugging power back to the board. Okay, I think we can leave the introduction here and move on to the next lecture, where I'll show you how to set up your Arduino IDE to work with the Arduino 101 and run a couple of example sketches on it.